Alright, welcome. An electron makes a transition from minus 3 point. Okay, so this is the initial energy level, minus 3.4 eV. Energy level 2 minus, that's the final energy level, that's negative 13.6 electron volts. Energy level, calculate the loss in energy. So that will be change in E equal EI minus EF. Now, what is EI? EI is minus 3.4 minus. Please, anytime you are solving, please take note of negative sign. It can actually minus in back. So this minus is this. YEF is this 13.6. So that will be minus 3.4 plus 13.6. So the answer to that is 13.6 minus 3.4, that's 10.2. So the change in energy equal to 10.2. Never forget your unit, electron volts. But now, the question is telling us to find it in joules. So what is the relationship between electron volt and joule? It's already given to us in the question. Now, 1 electron volt equal to, if 1 electron volt equal 16 times 10 to the power minus 19 joules, what will be 10.2? It's very simple. All you just need to do is to multiply it by 10.2. Let me write it like this. Now become 10.2 electron volts times 1.6 times 10 to the power minus 19 joules over 1 electron volt. So 1 electron volt, we cancel this. And when I find the value of 10.2 times 1.6, from 10.2 times 1.6 equal, so the change in energy level in joules is 16.32 times 10 to the power minus 19 joules. Okay, now question 2. The frequency of the emitted radiation. Frequency. So we all know that E equal H F. Now I ask for the frequency, so over H over H. So F equal E over H. What is H? H is Planck constant. So this will be 1.6. Sorry, 16.32 times 10 to the power minus 19 over the Planck constant is 6.6 times 10 to the power minus 34. This is very simple. So all I just need to do is write 16.32 divided by 6.6 is giving me 2.47. Now don't forget this, times 10 to the power minus 19. Division means subtraction over what? Minus 34. So this will give me 2.47 times 10 to the power of 34 minus 19, which will give me 15. What is the frequency? What is the unit for frequency? It is Hertz. I believe you know how I did this. Negative is positive. So that's how this answer was gotten. Now to question 3. Okay, let's solve question 3. Now, a photon of wavelength lambda naught is emitted from an electron in an atom, makes a transition from a level of energy 2 EK to that of energy EK. Okay, there is a full stop there. Now, let's translate all this English, all this grammar into a mathematical term. We all know that change in energy is En minus E naught, which is the ground state, the same thing as equal to HF, or is equal to HC over lambda. Okay, so let's talk about this. Now we have 2 to EK, so it means that the change in energy is 2 minus EK equal to HC over, they told us that the wavelength is lambda naught. So I'll not be writing lambda here, I'll be writing lambda naught. So 2 minus EK is what? EK equals to HC over lambda naught. I title this one as equation 1. Let me talk about the next one. Now, if the electron transition from 4/3 EK to EK level, determine the wavelength of the photon that will be emitted. Now, we're told that what was emitted from here is lambda naught. Okay, so now we are asked now to determine the wavelength of the photon that will be emitted from this second statement, this second instance. The first instant is from 2 to EK. Now, the second instant is from 4/3 EK to EK. So that will be change in energy, 4/3 EK minus EK equal to HC over lambda. Now, 4/3 EK minus EK, that should give us 1/3 EK. We got to HC over lambda. So this is the second instance. This is the first instance. Now we're asked to find this. Calculate, determine the wavelength by finding this. Now how do we solve this? Now we have two equations. So we're going to solve them simultaneously. But how do we do that? Now let us look at equation 1 and equation 2. You can pause the video and look for what looks alike. Now, okay, welcome back. We have EK here, we have 1/3 EK. They are not the same thing. We have HC, that is Planck constant times speed of light. And then we have Planck constant times speed of light in the second equation. So we can make HC subject formula in equation 1. In equation 1 now, if I want to make HC sort of formula, I'll just do over 1 with a cross multiply. HC equal EK lambda naught. Aha. So I've made that sort of formula. Now in equation 2, let's make it subject, let's make HC subject to the formula. So this times this will now be EK lambda over 3. Now if A is equal to B, if A is equal to B and A equal to C, can you tell me another thing that is equal? B is equal to C. If A equal B and A equal C, it means B equal C. Now, if HC equal this, EK lambda naught, and HC equal EK lambda over 3, it means that, in other words, what I'm trying to say is EK lambda naught equal to EK lambda over 3. Now I can now simplify. Remember, I'm making this subject to formula. So EK, we take away EK, and then this is equal 1. I cross multiply. Anyhow you want to find lambda naught. If you want to cross multiply direct, there's no problem. So the wavelength now is equal to 3 lambda naught. It's as simple as that. So the energy, the wavelength of the photon that will be emitted in the transition of 4/3 EK to EK level is 3 lambda naught. Right? So that will be all about energy quantization. We're going to come next time to discuss the other subtopic. Thank you very much.